So thanks everybody for joining. So the topic of discussion is how to save money and reduce your local law 97 exposure with cogeneration or CHP. So if you're not here for that, you're in the wrong class. Okay. So topics we're going to cover what is local law 97, what's cogeneration, or also known as CHP. I'll use those terms interchangeably. Who's Dalkia, Aegis, EDF group, and CHP is a solution to local law 97 or potential solution, as well as clients and case studies. So what's local law 97 and who's impacted? It's part of the Climate Mobilization Act, so basically passed by the City Council in April 2019 and effective November 2019. Applies to buildings over 25,000 square feet, as well as 2 more buildings on the same tax lot that exceed 50,000, and 2 or more buildings of that same size governed by the same condominium association. So why pick on buildings? Why the focus on buildings? So globally, buildings are responsible for about 40% of carbon emissions. But it's a bigger problem in New York City than it is globally. So in New York City, buildings account for 70% of carbon emissions, which is the equivalent of a large city by itself. So it might be surprising. I'm sure people assume transportation and vehicles account for a lot of greenhouse gas emissions, and they do. But buildings are certainly much greater by comparison. So the city's goal of 40% reduction by 2030 and a 80% reduction by 2050. So how do you comply with this ambitious goal? The first step would be to work with a certified energy consultant or an engineer or an architect who can help determine your building's energy usage. You're probably already familiar with the Building Energy Efficiency Rating. So you're probably already submitting the data that's going to be assessed in order to determine compliance with local law 97. So your benchmarking data, your LL97 data, your energy efficiency grading data is going to be looked at. So starting in May 1st of 2025, the report filed then is going to look back to the 2024 period to assess compliance with local law 97. So what are the limits? Different types of buildings have different limits based on their usage. Their limits are determined by how much greenhouse gas they emit per square foot. So since we're talking about residential buildings here, the limit for residential buildings is 0.00675 metric tons of carbon per square foot. The 2030 limit, though, is going to decrease significantly to 0.00407 tons of carbon per square foot. So, and then mixed-use properties have to comply with their respective usage. So if you've got a building that has retail, say on the ground floor, then their data would be assessed at the retail limit, the 0.01181, and then the proportionate share of the building that's residential would be assessed at the residential rate. So how do we calculate this? So first, we need the emissions factors published by New York City for each of the different sources of energy: electric, natural gas, steam, and so on. Then we have a hypothetical building to look at. Let me just minimize my. So our hypothetical building is 190,000 square feet. The 2024 to 29 limit, as we just discussed, is 0.00675. The 2030 to 34 limit, then, as we mentioned, 0.00407. So for the 24 to 29 period, our limit is going to be 1,282.5 tons of carbon for that building. Then the 2030 to 34 limit is going to be reduced to 773.3 tons. So our hypothetical building uses 2.2 million kilowatt hours of electricity. So if we multiply that by the electricity factor, we get 635.7 tons of CO2. And then we do the same with the natural gas. 170,000 therms of natural gas gives us 902 tons of CO2 per year. So for a total 1,539 tons, or 256 tons over the 24 to 29 emissions limit, and 765 over the 30 to 34 period. The penalty for the excess amount is $268 per ton. So we calculate that by then taking the excess for the 24 to 29 period of 256 and multiplying that by 268, which gives us a penalty of 68, almost 69,000 for the 24 to 29 period, and 205,000 for the subsequent period. So what can you do to reduce exposure? We'll talk a little bit more in detail about CHP shortly, but in general, any energy efficiency projects can help reduce exposure to local law 97, and these projects also have their own savings and ROIs associated with them, so they can be beneficial both from a savings standpoint as well as from a reduction of local law 97. Rooftop solar, LED lighting certainly is something that many buildings have already engaged in. Energy efficient windows, cogeneration, which we'll talk about today, and a lot of times, especially for larger buildings, it's a combination of these projects. So talking a little bit about now what's cogeneration or what's CHP, which is it's just simply the production, the simultaneous production of usable heat and electricity from a single source. So in this case, natural gas producing two beneficial outputs. We take in this graph, we have on the upper left, we have our hypothetical central station power plant, and for simplicity, we use 100 units of fuel, 100 units of natural gas as the input, and that results in 30 of those units, or 30%, generating electricity that's delivered to the grid. The other 70% basically kind of being rejected up the stack as unusable. The lower left-hand side is an image of what one of our units looks like. 4 by 8 basic footprint. So we take that same 100 units of fuel input, but instead of having so much heat lost up the stack, we have the same 30 units of electricity delivered, but we also have 55 units of heating delivered for space heating or domestic hot water usage. So how does that translate to carbon and carbon footprint? So that central station power plant might say, well, that's not my responsibility, but your proportionate usage of electricity from that plant is your responsibility. So that 2.2 million kilowatt hours of electricity that we discussed before, that comes into the building, the carbon footprint from that central station plant associated with that becomes your responsibility. Similarly, you have gas coming, or you have some other gas or oil or some other way that you're heating your building. In this case, we're using boiler gas, and that's those two things together get us a combined number of tons of CO2 per year. The CHP or cogeneration process is simply more efficient. We're now making electricity on site behind the meter, and we're reclaiming the excess thermal energy from that process, and we're using it for space heating and domestic hot water. So the end result is about half the amount of carbon as is the case with the central station plant or grid power usage plus boiler. These figures come from the US EPA, by the way. So this is just a quick, this is what our unit looks like kind of without the cover on it. The central blue parts are a reciprocating engine coupled to a generator, turning a generator. When we do that, that process generates a substantial amount of heat. The red areas identified are all areas where we're pulling heat off the unit and reclaiming that heat to create hot water, which in turn interfaces with the building's hydronic heating system and domestic hot water system. Who are we? Dalkia Aegis EDF Group. We started as a family-owned business in 1985, and for the last 35 years, we've been doing just cogeneration. We've grown to a national company, although we're primarily focused in the New England to DC area because of the high energy rates in those areas, and have well over 1,000 CHP installations. A few years ago, we were acquired by EDF Group, which is considered by many to be the largest power generation company in the world. Specifically, we were acquired by the Dalkia unit of EDF, which is Dalkia's global energy efficiency division. So in addition to giving us a substantially larger balance sheet and financial backing and financial resources, it gave us access to a wide range of additional energy efficiency technologies. So now we're not just a CHP company, but we can implement rooftop solar, community solar, LED lighting, and a host of other technologies. Our competitive advantage, in short, we do try to do everything all under one roof. So from the initial energy analysis of the property to the design of the system, we manufacture the system in Holyoke, Massachusetts, and then we install, maintain, and monitor the unit. We have our central monitoring group, which monitors our units 24/7, 365. We, through our additional resources, through our acquisition by EDF, have substantial resources to finance projects now. So having a single source of accountability makes for, simply in our view, makes for a better project. So what are ideal building candidates for cogeneration or CHP? So buildings heated by, with hydronic heating, heated by hot water. The minimums in terms of therms and kilowatt hours that we mention here are probably any building that's looking at a local law 97 issue is probably easily meets those requirements. Same with the number of apartments. Certainly, these are going to be larger buildings with 100+ apartments. We don't only obviously do multifamily housing, but it can be applicable to hotels and other types of properties as well. Ideally, we're gonna backfeed and we're gonna offset electric consumption. So we want to have master metered or sub-metered buildings that are directly metered with tenants paying their electricity directly to utilities, or might not have enough critical mass for cogeneration, but if there's substantial common area electric usage, then it might be. And obviously high electric rates they're not a problem in New York City. So to kind of summarize the benefits of CHP, typical net savings. So local law 97 aside, these are projects that generate good ROIs, typically in the 3 to 7 year range, and savings net of any maintenance costs of 15 to 55%. Carbon footprint reduction, which we're here to talk about today, so that's obviously a benefit. Reduce boiler related costs. So the boiler really becomes the backup to the CHP unit. So the boiler is going to operate substantially less resulting in substantially less costs associated with that boiler. Our financial resources position us to offer no upfront capital options, so we can structure CHP projects as PPAs or energy service agreements, where we can sell energy at a fixed rate to the client rather than have them acquire the unit. But either option is certainly available. We always integrate maintenance of the unit. We have our maintenance crews locally in New York City and any other markets where we operate for same day and next day maintenance, but we also monitor the systems, as I mentioned, remotely, and oftentimes any issues or maintenance issues can be resolved remotely. Lastly, there's significant federal tax benefits associated with these projects, some of which are going to go away at the end of this year. So projects that are being considered, it might make sense to consider commencing them before the end of the year in order to take advantage of some of those benefits that are going away, and it's unclear if they're going to be renewed going forward. So talking numbers, here's kind of our, this is an actual building, an actual client of ours, where we installed the 150 kW CHP system. The pre-CHP energy spend of about $550,000 a year, split between electric and natural gas. We see the savings of about $155,000 resulting from the installation of the CHP system, bringing the net spend after maintenance down to just under $400,000 a year. What the graph illustrates, you can see the lower left graph illustrates the electric offset of the unit. So the electricity being made on site is the solid blue area, and it represents most of the overall consumption of the building. So the building's really remains integrated and connected to the grid and is taking in electricity, mainly during peak periods, during high energy consumption periods. Same thing from the thermal side on the right side of the page. You can see that the unit is pretty much providing the base thermal needs of the building, and the boiler is only represented by the solid blue area. And again, the green areas are the periods where the boiler is kicking on to augment what's being provided by the CHP system. So now we're going to come back to our original example, and we'll talk about how we can solve the local law 97 penalty issue with CHP. So we had our original hypothetical building of 190,000 square feet, 2.2 million kilowatt hours, 170,000 therms of natural gas, and penalties in the 24 to 29 period, as well as the 2030 to 2034 period, because of the excess tons of CO2 created by the current grid power coupled with the boiler plant. So we take the same building and we implement 150 kW of CHP like we did in the last example. That brings our grid electric consumption down to 1 million kilowatt hours a year rather than 2.2. The usage, the CHP unit is using gas and displacing gas from the boiler, but sometimes that ends up being a little bit more than was previously used by just the boiler alone. So the boiler gas, the combined boiler gas and CHP gas has gone up. But the net result is that the tons of CO2 created from electric consumption has gone down. It's basically cut in half to 289,000 tons per year. The natural gas tons has gone up a little bit, but in total, we're at 1,271 tons versus our 1,282 ton limit. So we're actually under for the 2024 to 29 period. The 30 to 34 period, which is obviously a much more stringent requirement, we're still over. You know, I wanted to show this, even though it's a hypothetical, I wanted to show this because this really is a more realistic example. The 30 to 34 period is an ambitious goal, and it's going to be tough for some of these larger buildings to meet that period without implementing substantial or making substantial changes. So we look at the $268 per ton penalty multiplied by the excess for the 30 to 34 period gives us still $134,000 penalty. But remember, we're generating $155,000 in annual CHP savings, which more than offsets the 30 to 34 penalty. But better still, and I think the real way to think of this is this is really a bridging technology. So during the 24 to 29 period where you're earning the $150,000 savings, that could be money that's being put into additional energy efficiency measures to bring the building in compliance during the 30 to 34 period. Just wanted to give an actual example of an actual customer we've worked with. We do a lot of the Avalon Bay buildings. So this particular building, Avalon Fort Greene in Brooklyn, the 200 kW installation had a capital cost of a little over $1 million. At the time, there was a NYSERDA incentive that's no longer available, but as I mentioned, there are federal tax incentives. So the net project cost in this case was just under $700,000, generated net savings of just a little bit over $200,000 a year for simple payback of 3.1 years. How does that affect the carbon footprint of the building? We can see that the grid electric consumption of this building went down by almost 70%. So it's a substantial reduction in the calculation with respect to tons of carbon of electricity for this building, and 31% of the thermal load of the building is being supported by the CHP. So that kind of wraps up my presentation, just to kind of summarize how we typically work. So to assess a potential project, usually the first step is to get some data, 12 months of utility bills and natural gas commodity bills and electric bills, do an initial assessment, do a site visit, do a utility grade energy analysis, and then ultimately do preliminary system design to present a proposal with hard economics to be assessed by the end user. Got my phone number and email address below for the. I'm not sure how much time we have for questions, and I'll certainly be happy to answer any. But if you'd like to reach out directly or get some additional information or a copy of the presentation, feel free to shoot me an email or text or give me a call. Thanks very much for your time.
Mike, I think we have just a couple minutes for questions. Just depends if you'd like people to enter them in the chat or just unmute themselves. And if they don't have questions, if there's a takeaway you want to share, we can jump into that too. Do you have a preference on questions?
I'm fine either way. There's the question, one of the questions in the chat that I'll respond to. Can you clarify the rationale for investing in CHP now that the ultimate goal is to remove fossil fuel systems and electrify and decarbonize buildings? I think that the ultimate goal is to try to decarbonize, and I think as illustrated by the example, the efficiency of CHP systems and behind the meter or local generation provides significantly decreases the carbon footprint versus central station power plant. Additionally, as I mentioned, it's kind of a bridging technology. We have limitations right now in terms of what's possible. So CHP is a technology that certainly can both offer economic benefits as well as reduce a building's carbon footprint. It's certainly something that can be used or used in conjunction with other technologies like solar or other energy efficiency projects.
Great, thanks. It looks like somebody else was asking for the slides, and if you want to email those to me, Mike, I can upload them.
Sure.
Great. Perfect.
All right. So I guess if we don't have any other questions, I guess we'll wrap it up, Miriam.
Yeah, sounds great. Thank you for that. I'll put the
Thanks,
slides on
everybody,
that
for,
conference platform. So thanks, Mike.
Thanks everybody for joining. Take care.